Hello, my lovely applied mathematicians. So we're going to look at the 2023 question on shortest path in the network and to find the shortest path by implementing Dijkstra. Question here is university, paths, campus. It doesn't really matter at all. It's the only thing we really need to be able to do is know what the answer is going to be, or the units, or the what we're trying to shortest path on. And here it is money. The cost of carrying out the improvement work for that path. So we have a bunch of nodes, and so x to y, and then the weights of the edges are the cost to improve the path between those two nodes. So the first part is to have an improved route between x and y. Use Dijkstra's algorithm to find the route between x and y that is cheapest to improve, and then calculate the cost of such improvements. So we want to find the route from node to node to node between x and y that is the cheapest, the one of least weight. And we can do that using Dijkstra. If it was a most thing, we'd have to use Bellman and dynamic programming, but at the moment it's least, so it's Dijkstra. And this problem doesn't really lend itself to the dynamic programming anyway. So what I'm going to do, I'm going to talk through the algorithm and what it is, and how it would be implemented in the graph if you were to solve this for yourself. And then I will do it again, but with kind of an exam-focused way of writing out your answer, because it does say relevant supporting work must be shown, and if you just draw it all on the graph, you might get the right answer, but I'm not sure you'll get marks. So I will go through the process by marking the graph and highlighting things and just showing what I'm doing, and then I'll do it all again in an exam-centered way, and we'll hopefully get the same answer, and if not, then we'll figure out what's going on. So part one is explanation of the algorithm. So with Dijkstra, what we do is we have our starting point. And our starting point here is x. And at x is 0 distance away from the point x. So our starting point is 0 away from where we started, which makes sense. What we then do is from x, find the distances to all other nodes that are connected to x. So in this case, it's A, B, and C. So we have A, B, and C. So our three options to go from x are this, A, B, C. So what we do is we figure out or calculate the total distance so far from x to A. So it's 0 plus 3400, and that's 3400 is our current shortest distance to A. 2500 is our current shortest distance to B, and 1250 is our current shortest distance to C. So now we've written out all the ways we can get from x to something else. And once we've done that, once we have gone through every edge that's connected to x, we mark x as visited, and I'm just going to color them in red if they're visited. Hopefully that'll gradually make sense. So now x is visited, we never need to come back to x, because we know those three numbers we've written are the shortest way to get away from x. So what we look at now is what's the smallest number we have in our active nodes. The active nodes we have are the ones we've just drawn lines to, or the ones which have distances that on them. If we haven't touched any, like say this point here, M, we have no idea about that distance, so we can't do anything with that from that yet until we know how far away it is from x. So what we do know is we know A is 3400, we know B is 2500, and we know C is 1250. So we have those three options to work with, and we take the smallest one. So that is 1250. So 1250 is our shortest distance from X. And what we do then is we see what are the distances, the cumulative distances from C to B and C to F. So we're going to calculate the weights of the path, all the paths that come out of C, including the distance that's at C at the moment at 1250. So what we've got, and the graph is going to get messy, but we'll cope with it for now, is 150 to go from X to C to B. And what's that? That's 5. That has crashed. No, 150. 150 to go from X to C to F. And C is therefore visited because we have worked out all the weights from the node C. Now, you'll notice now we've got two distances at B. And what we look at that is we see which one of those two is the shortest, the smallest, because we're looking shortest path, and it's a 150. So what we do is we know that getting to B, the quickest way is to go X, C, B. So that means that this path, the X to B, the 2500, is not the shortest. So we just dispense with that. That is no longer our shortest route to B. So now our live nodes are A, B, and F. And we have to go which one of those is which one of A has the smallest distance, which one of A, B, and F has the smallest distance, the smallest weight from X, and that is B at the moment. So we look at B, and we go from B. From B, we're going to do that, and we're going to see what that gives us. So from B to G is 6,350. And from B to F gives us 4,250. And B is now visited because we have looked at every single node that's connected to B. And we see at the bottom at node F then that 5150 is no longer relevant because there's a better way to get to F. You don't go XCF, you go XEBF. And so now we have our current nodes now are the ones that we can do something from are A, our G, and our F. Which one of those is the smallest number? It's at A. So we then calculate A to D and A to E. So A to E is 4200 and A to D is 6050. And we mark A as visited. We don't need to consider that again. So now that hasn't changed anything with the current points or current available nodes, but we now look at E, I believe it is. Yeah, E, 4200. And so we go E to D for 1750, so that gives us 5950. Which means E is visited, and it means that 5950 is now our shortest distance. Shortest distance to D. Now, just come on there. Did I make a mistake? No, I did. did. Hopefully some of you have been screaming. I knew just something wrong with that number there. So 250 and 250 is not 4250, it's 4300. Didn't change the thankfully didn't change the order in which you did stuff, but it did. So now it did. The final answer might be different, so let's just be careful with that. So our current nodes or live nodes are D, G, and F. So we are F is the smallest one. So let's look at F, and it goes 5900 to H and 6500 to I. And F is therefore visited. Now, H is our smallest one by 50. So let's look at H, and so H down to I is 700, and H up to G is 7250, and H is visited. Cool. But now, actually, this is the first time where we're going to see something, or just be aware of something interesting, and then H to G is longer than getting to G somewhere other way, so that's not a way in. And H to I is also longer. Okay, so there's no route of H from H that is in the shortest path, if we can see it there. And this means we can get rid of H. H is definitely not in our shortest path. There's other points will slowly not be in it, but at the moment H is the first point we've definitely gotten rid of. It's useful to do this so that when you're trying to track back what the shortest path is, it's easier for you to see what it is that is, I suppose, what's gone, what's not to be worried about anymore. So we're at D, G, and I. D, G, and I. So D for 5950, and that goes to G to 6600, and it goes to J for 8950. Okay. So, well, that D to G is not useful. D to G is not useful, and D to J, who knows, we'll see. Then the next one we're at is, and actually we know that D is visited because we've just left D for the final thing, so we don't care about that anymore. So we see our next thing, and this is why marking the visited thing is important. This is the next one we're going to look at, and if we hadn't marked D visited, we'd be wasting time going up from G to D along this path here, which is something we don't want to do. So mark, and because we'll do it and we'll find it's longer, and so that won't be in our shortest path, but it just will have been a waste of time. So let's not waste our time if we can help it. It doesn't matter if you do it by mistake. You can't, it's not going to get, you're not going to get the wrong answer. It's just time that will be best served on something else. So D is visited. So let's say the 6350 from G only goes to one place because H is visited, so it only goes down to 8850. G is visited. Where are we at now? We've got J, K, and I. So I is the next one. So I has two options to move from. It is 8850. What is it? I is, no, did I get something wrong here? I think I added up something wrong. I6500. Just let me check 1 second. I'm having a momentary, what have I done wrong? Phase I50 and K is 9850. Why is that 9850? There must have been a mistake in the paper. Okay, so I'm looking at the marking scheme here and something has gone strange on that. But we'll continue on and then I'll come back to it if necessary. So 6500 up to K. Just let me check the question on the marking scheme, because that's a strange one. Okay, sorry, I don't mean to have a pause there, but something strange has happened with the question. So what I'm looking at is 650 plus 2350. Just the marking scheme is telling me something else, but I'm just going to say 8850. There, so we got two possibilities now into K for the same thing. And then we have 250 from I to L, and I is visited. So I to K and G to K are giving us the same answer. So now we're looking at, we have J, K, and L as our options of K. So to go from K, we go up, and that will give us 10750. And then we go to from K to M, which gives us 11250. Let's see, from K, G to K, 250. And then down to L is 10700. Now, okay, cool. 10750, sorry, 10750. So I'm getting all backwards now. So K is now visited. We've left K and gone to everywhere, and we've found that 10750 is the quickest way to get to L. It's not the quickest way to get to J, so that 8950 is still there. So let's look at the 8950 from J. That's the smallest of our three live points, J, M, and L. So that would be 9900, which removes that from consideration. And actually, just to pause, go back a little bit, just to remind us of this. See that 11250 being removed from consideration. This here means that anything that is only part of that path has to be excluded. So that's 650. No, well, okay, that 650 is quite likely to be gone, but we'll look at it in this. We'll look at it in a second, because that is still part of that I path, but I think that's going to be taken away from us. And then we have, where are we at? What's our smallest one? So we have J is now visited, because it was just that 1 point we had to worry about. Now M, we go to Y, and that gives us 11450. And M is now visited because that was the only one outstanding for M. Now L, we go 10750 plus 2300 is 13050. So much wrong. I have to do this all again. Spotted another mistake. I'm over confusing myself. Where are we at? Okay. Here again, and I suppose I leave these mistakes in because I want to show that mistakes happen. I did prep it and I did get the answer about 5 minutes ago, but it's very easy to get confused when you're trying to keep everything in track, and I just wanted to show you that. So I have made a mistake way back. F to I650. Oh yeah, no, the marking scheme is wrong. Right. Cool. So we're at this. So 8850 plus 950 is 98800. Now we do know that's gone and that's gone. And the 8950 plus the 950 is 9900. So now, and that 1250 is gone from there. So, and K is visited. So the next one to look at is L for 9800. So that's 9800 plus 2300 is 12100. 9800 and 1950 is 11750, which means L is visited. Now we look at the M. M, we only have to connect up to Y. So M is 11450. 11450. Which is the shortest distance there. M is visited. But now we've got to Y. It means we've got to everything that is, N is now visited because we have got to every node that can connect to N. And so we know that's not part of the shortest path. So we now have to kind of track back where the shortest path is. So the shortest path is going to be here, here, it's not either of them because they are the 10750. I should have connected that up, and then this goes to here, and then EAX. So the shortest path, and you'll see the shortest path is the collection of points that I haven't, like the only path that is connected with points that are not drawn through. And that's why I drew through them, so I can know that they're not part of the shortest path, even if I did forget the odd one here and there as I was going. So the shortest path there is that. Now, that's my explanation of it. I'm hoping that when I do it again in an exam focused way, it's a little easier for you to get your head around. So the shortest path is X, A, E, D, J, M, Y, and the cost is 11450. and there is a mistake, and I reckon that should have been a 3 there, because that's what the marking scheme is saying. So I reckon there's just a little mistake there, but it didn't actually affect the thing overall anyway. So okay, so now what we're going to just implement it in an exam. So we're going to start fresh, and we know what the answer is in theory. So what we do is we look at our first point. Okay, and I'm going to type this now with the, so we're going to say x, and that goes A for 3400, B for 2500, and C for 1250. So they're the options that we can go from x. And x is now visited. We then take the smallest number that we have in our live points, which is C. And from C we get to B and F. So B is going to be 1250 plus 900, so that's 2150. And F is 1250 plus 3900, and that gives us 5150. And here now we say that C is visited, mark it on the graph, and we can also now, we can cross out the B to 2500, because we have a 2150. Now I'm hoping that the sums are obvious. So 1250 plus 3900 gives you your 5150. 1250 plus 900 gives you your 2150. So we've written that down. We have, it's the first time we've eliminated a possible route, a possible edge from our shortest path, which is our 2500. And now we look, what's the smallest number we have available to us in our live points? Remember, C is visited, so maybe we can just put a little line through C, or the red underneath, because I've colored that red. So some way of remembering what's going on for yourself. So what's our smallest unvisited point? There is B 2150. So it might even be easier if you say x0, C 1250. Then B, we're at 2150. And so from B, we can go to G for 4200 and F for 420 plus 2150. So 4200 plus 2150 is 6350. And then F is 250 plus 250 is 4300. 4300. So now we look, so B is visited, so we can cross that off. And we can say now, what we can say now is, that one, that's annoying. Are we discounting any option? Well, F for 5150 is not an option. Because we have that 4300. Okay, so we've discounted that. So now what is the next place to go? What's the smallest number so far? B is visited, so B, I'll put that little line underneath it. It is no longer, we visited that, we don't need to do that again. What's the smallest of our unvisited? It is A for 3400. So we do that. So we go A 3400. And please go back and pause it and just get your head around what I've been saying. Ask me to slow down if you want in the comments and I'll do it again. Or just put it on half speed if you can cope with that. So where are we at? We're at A3400. and that lets us get to D for 6150, 6050, yeah, 6050, and lets us get to E for 4200. So that means that A is visited, and I'm just going to put a line under A there. And has that changed anything yet? No, because all that has done is added D and E to our points. It hasn't removed any of the other ones from consideration yet. Okay, cool. So now we have our options, our unvisited ones, just to recap. Unvisited points are G, F, D, and E. So what we do now is we, again, pick the smallest one, which is our E, 4200. And see where we're going from E. And from E, there's only the 1 point D for 1750. So 4200 and 1750 is 5950. 5950. 5950. And E is visited. And I'm going to have to start scrolling up and down now just because of the less than fun stuff going on here. So 5950. So E is visited, so I'm going to just put a little line under E in our table. And then, are there any of them? That D for 6050 is this one here. Is gone because that's slightly bigger than the one we've just figured out. So I'm going to get rid of that. And now that has reduced something. So now we have 3 live points, G, F, and D. So just to kind of see where we're at so far, what we have available to us are, that's one possible route. That's one possible route. These are our current shortest paths, I believe. And that one. So there's the 3 possible candidates for the shortest path so far. And as we go, hopefully we'll see that we get something a little bit more useful. Or we'll see it get clearer and clearer. So now, where's that? Where's the smallest number now? It's actually D for 5950 is the smallest unvisited point. So it's that D. And so what happens there is D for 5950 goes to G and J. So for G, it's an additional 600, so that's 6600. 6600. And to J is an additional 3000, so that's 8950. Okay, has that helped? Well, yes and no. I suppose D is visited, so we can just put the line under there. And then that route we got to G is irrelevant because that's bigger than the one we already had from B. So now D is visited. Excellent. What do we have live now? We have G, F, and J now. So of our numbers, F4300 is our current shortest distance. So let's see what we need to do for F. Seeing as F needs to be visited. What is going on with that? Let's try and tidy things up and it never makes it nice. Okay, so F goes to H. It's already gone to B. We don't need to go back to B because B is visited because of the red mark. H for 1600, so that's 5900. And I for 6500. So has that done anything for us at all? No, this is just added in a whole bunch of other points. F is visited, I suppose, so F it's not one of our live points anymore. That is done. So now we're at that. So now we have G, J, H, and I to go. So what's the smallest one? H for 5900, I think. So H 5900. And where does that go? That goes up to G. And it goes up to, or down to I. So G, so 5900 and 1350 is 7250. And I is 1800, and that is 700. So now I notice that the green line over the G6600 is there, but what that's not saying G is visited, is saying that particular route to G is not the shortest path. So there still could be other ways to get to G because we haven't got G fully visited yet. So it's important just to know why I'm crossing out things and why I'm underlining things. So the crossing out is that they are no longer no longer the shortest possible path. And then the underlines are just the visited points, which may or may not be part of the shortest path. We don't really care. We're just trying to find the shortest path. So what this tells now, we have I for 700, so that's bigger than our 6500, so that's not shortest. And G for 7250, so that's not shortest either, so that's gone. So H is both visited, I think, and H, I reckon, is no longer part of that conversation because anything from H is not part of the shortest path. Okay, so now what's that? We have D, J, and I left. So D is visited. Sorry, we have J and I left. Do we not have? Wait a minute. I have. G as well. For 6350. So G for 6350. Okay. You'll notice this was up here, and I just didn't spot it when I was looking because I was looking down here. So just be careful to make sure that you know what's going on. Maybe even use a highlighter in your exam to help you. I know only the pen will be visible, but at least it'll help you, which is what's important. So G for 6350. Or sorry, only the black pen will be markable, but it'll help you get the right answer, which you write in your pen. So 6350 from G. We only need to go to K actually, so that's K for 8850. So okay. So now G is visited, and that's our first K, so we can leave it at that. So what's left now? We have our I 6500, our J 8950, and our K 8850. So what I would do now is I would say, let's see if can I type put this. Let me type it up here now. So the smallest number now is I6500. So just write that down and then see what that gives us. From I, it's 2350, and to K and 4750 to L. So to K is 2350, so that's 8850. Now the marking scheme says something different. I reckon there was an error in the numbers and they changed it, but they didn't change it on the actual paper. Don't quote me on that one though. And then L is 4750, which is 11250. So what that has done is it means that I is visited. Put little colors on the graph and put a little line under it. And we now have two current shortests. They're both at K. So K 8850 is what we're going to start with. So from K, what happens? From K, we can go to J, M, and L. Okay, so it's going to be K to J for 1900. So 1900 plus 8850 is 10750. To M for 2400. So that gives us M 2400. What is going on there? So that gives us, sorry, 2400 plus that is 1250. You can't see the confused face I'm making. 2400, okay, well, I don't think it'll matter anyway. 8850 plus that is 1850, and 400 is that, okay. Let's see now where we at. So then we have, so what has that done? Has that done anything for us yet? No. So the to J is too long. And we also have to do the L, which I totally forgot. So 8850 plus 950 is 9900. So what that does for us is that takes that L out of consideration. So now we have K is visited, so we don't need to worry about those two. K is visited. J is not yet visited because we haven't dealt with all the edges yet. J. So where are we at? J for 8950. So J of, oops, what the hell happened there? J for 8950. So add a 950 to go to M, because the K is already gone, so add a 950 go to M, so that gets you M at 9900. That's it, and what that does, actually, that takes that M 11250 out of the equation altogether, which I think is going to remove K from the equation altogether. But we'll have to figure that one out in a second because it is confusing. So J is done. And you can see why I suppose I like using the graph, because it helps you kind of track what's going on the graph itself. Whereas this, you keep having to look back and forth. Where are we at now? We have J is visited, so I'll put J is visited there. We now have L and M with the same distance. Wait a minute. 850 and 950 is 9800, not the other way around. Sorry. No, it's this one here. So the reason I saw that is that those two being the same just gave me a little bit of a worry. I just wanted to check, and I saw that the 950 I'd added on too much from K to L. So what do we have live now? Live we have just L and M, I believe. So which one's smaller? L. So it's 9800. And so from L is 2300 to Y and 1950 to N. So Y 2300 12100 and then to N 1950. So N 1950, which is 11750. Okay, and L is visited, and that's the first time we've hit Y. So we have a maximum for Y is 12100, or not a maximum, just a big value. So we know if we get anything else smaller than that, we can replace it. So what's next? So that would be, that's L visited. Then we go from M, I guess. From M, we say it's only 1 point actually, isn't it? It's 1550. Okay, so from M, from 9900, we go to Y for 1550, which gives us 11450, which is definitely smaller than that. And M is visited. And now we don't have to do anything else now because we've got our answer, and this N is, that N is bigger than the number we have for Y already, so we don't actually have to get to, we don't have to calculate from N to Y. Some implementations of Dijkstra say that every single point must be visited. I reckon we can probably say just a Y is visited now because we can get to every point that touches on. So we have gotten to every point that touches Y. So we've gotten to M, and we've gotten to N, and we've gotten to Y. So we have gotten to every point that touches Y, and we've gotten to Y, and we know we have guaranteed the smallest number, which is the cost is 11450. Now, how do we understand what we've done here to track back our answer? This is the difficult part. Like, what we've done there, we've used it to work out, and I think it makes sense. But how do we figure out the root, which are kind of path took? So what we do is we start at Y, and I'll just use the yellow highlighter for this one. So we start at Y, and we look at where we see Y here. And where did that come from? That came from M. Okay. Then we find the uncrossed out M, which is this guy. And where did that come from? That came from J. And I'll highlight it up there. Then we look for the uncrossed out J, which is all the way here, which is 8950. And where did that come from? That came from D. Then we look at the uncrossed out D, which is just that one. That's why it's really important to cross out as we go, so that we can just work backwards and trust what we've done is correct. Then we look at the uncrossed out E, which is 4200. And that went to A. And then the uncrossed out A is that one, which goes to X. And that way we can track backwards very quickly because of the method we have employed to track our changes or track our shortest path as we go. So the shortest path is X. I'll just use math mode for this. X to A to E to D. X to A, X to A, to E, to D, to J to M to Y. And that is your answer. I don't know which method I prefer. I think I prefer working on the graph, but we do have to have some way of showing the work we've done, and this kind of just writing out the distances from each point as we get to them is probably the most sensible way of doing things. So points wise, so this was worth 20 points in total. I'd imagine if you get your 11,450 correct, you get your 20. Or if you either write down the path or the cost correct, you'll get 17. So in terms of points, it's one of these is 17 marks, both of them. So or is 17, and for both is 20. Then we're looking at 14, 8, and 0. So 0 would be obviously nothing at all. 8 would be some correct implementation of some aspect of Dijkstra. And that might even be just getting through, I'd imagine it would be doing XCB. I'd say getting to there would be 8. And then sort of getting somewhere down here would be your 14. So I might be being too mean there, maybe starting at all. Writing the distances from X could be your 8 marks already, but that's roughly what I'd imagine it would be like. So it's 8 out of 20 is 40. So just by getting some correct step, you're going to pass. Obviously, you want to get 20 out of 20, but just so you know that at least you got something right, and then you can move on. I feel like that went very fast, so please let me know if you'd like a further explanation. And thankfully, we did get the same answer and all the same figures, I hope. Yeah, we did. Cool. Apologies for the confusion in the middle, but that was due to the marking scheme and me not paying attention when I did it out prep-wise just before. Anyway, have a good one. See you guys later.